Now, this one. It's a good one. On this example, we actually have three restrictions. We have a radical in the numerator, right? So now our numerator is not a continuous function, but it has a restriction, right? So we have to take into account this restriction. Would you guys agree? OK, we have to take restriction of first radical. Then we have a radical in the denominator. So now we have to take into account that restriction. Yes? So that's two restrictions. Then, to make matters worse, we have a fraction. That means we have a denominator that cannot equal to 0. So we have to take into account that third restriction. So it's not as easy as the first one, where it is, whatever number is greater than or equal to 0. We have three restrictions in this problem. Kind of a little crazy, right? Right? But I'll show you. Well, let's kind of write them out for each one, and then I'll show you guys how we can help simplify our work. So let's just do the first restriction. I got time to finish everything. You don't need to put anything away. Would you guys agree? These are my three restrictions. Yes? Radical in the numerator has to be greater than or equal to 0. Radical in the denominator has to be greater than or equal to 0. Denominator cannot equal, or has to, whatever number the denominator equals 0, that's not in the domain. Right? OK, so let's kind of do this one. Guys, you could just add the x to the other side, but I'm going to solve it using inverse operations just because I want to remind you. Remember, guys, whenever you multiply or divide by a negative number, you have to flip the sign. Right? Just remember that. It might be easier just to add the x to the other side, but we'll go through it. Here, let's just add the 2. Oh, OK. So here's where we can actually simplify our answer. OK, so we got x has to be less than or equal to 4. Now, right now, I wrote x minus 2 has to be greater than or equal to 0. Well, guys, does it make sense for my radical in the denominator to be equal to 0? Should our denominator be equal to 0? No. So guess what? By me just removing this line, saying my denominator has to be greater than 0, it can't be equal to 0, I no longer have to do the math for that. Because now I'm just saying I don't want it to equal 0. I just want to find all the values where it's greater than 0, not equal to. Stop putting things away. I have plenty of time, guys. So that means x has to be greater than or equal to 2. So now we graph this. Now this is kind of confusing. We have 4, and we have 2. X has to be greater than 2, but x has to be less than or equal to 4. So where should we graph? What's our solution represent? Yes?
Where they overlap.
The intersection, right? The intersection of the two. The domain has to be true for both of them. And if you're unsure about that, just pick. Why don't we pick the number 0? The 0 is less than 4. But does 0 work for this one? No. So the domain has to work for both of them. So my domain would be -2 to 4. One with the parenthesis, one with the bracket. And I apologize. I'm kind of overtalked my space real quick.